Hi Lakewood, and welcome to another lesson on the distributive property. One definition of the distributive property says that it is numbers added or subtracted within a set of parentheses can be multiplied by a number outside of the parentheses. And we can look at some examples, and if we look at the numbers here and you say, well, yeah, what's the big deal with that? Well, it can come in kind of handy when we get problems that we need to do in our head, like 8 times 79. Because that's not an easy multiplication problem to do in my head. But if I split it up into 8 times 70 plus 9, then it becomes much easier to do. It is also going to become very handy when we need to simplify expressions and we have a variable and we cannot add an x to a 9. So let's see how it works. The example of distributive property says I am going to multiply the 8 times the 5, and then I am going to add it to the 8 times 3. Basically, it says I can add my numbers first and then multiply, or I can multiply and then add. And there are different times when we want to use each one. It works for subtraction as well. 8 times the quantity of 5 minus 3 is the same thing as 8 times 5 minus 8 times 3. So let's watch and let's see how this works. Here we have two expressions, and they want us to simplify them using the order of operations. We can do this. I begin on the left. Order of operations says I need to simplify my parentheses first. 20 plus 9 is 29. 7 times 29 is, over to my work zone, is equal to 203. Let's look at this one. Order of operations say that I need to multiply before I add. So 7 times 20 is equal to 140, plus 7 times 9, which is 63, and those add together to be 203. The same answer. This one was much simpler. I did not have to go over and do the work. So this is an example of when I have the problem 7 times 29, that this expanded form is much simpler than this form. Let's practice some more problems. Use the distributive property to expand each expression. Remember that expand means to make something larger, to spread out. And then we're going to evaluate the expression. Evaluate means do the math. So I'm going to expand the expression first. That is step 1, and then I will evaluate. So I like to use arrows to help me see the math. I start by saying 3 times 4. 3 times 4. Then I'm going to add it to 3 times 7. 3 times 7. Now I do the math. 12 plus 21, and when added together, the answer is 33. We can do the same thing with subtraction. I'm going to expand by saying 10 times 18. This time it's a subtraction. 10 times 2. Following the order of operations, I get 180 minus 20. And the answer is 160. Please remember that this is the expanded form. and the directions ask for us to do both the expanded form and the value of the expression. Now I'd like for you to practice these two and check back in with your answer. Okay, let's see how you did. The solution to the first one is 195. But remember, we had to write the expanded form first. So, as you can see, I have 5 times 9 and then 5 times 30. I do the math for each set of parentheses, and my solution is 195. Works exactly the same as subtraction. The only difference is that since I have a subtraction sign here, I have a subtraction sign there. 2 times 9 is 18, 2 times 4 is 8, and the answer is 4. Another way to use the distributive property is to use the area models. The area models say that you can represent the distributive property using area models. To find the area of a rectangle, you multiply the length times the width. Old information. So let's look at an example. Suppose you want to cover the tops of 2 tables. One table is 5 feet long and 4 feet wide. The other is 5 feet long and 2 feet wide. Find how much paper you need to cover the tabletops. Well, I know that I have 2 tables, and I can find the area. The first table is 5 feet by 4 feet, and the second table is 5 feet by 2 feet. So I can do this the old-fashioned way, and I can say one table that is 5 times 4, and the area is 20 feet squared. The other table is 5 times 2 feet, which multiplies out to be 10 feet squared. To find the area of the 2 tables together, I would add the 20 feet squared to the 10 feet squared to get 30 feet squared. Let's look at the way that we could draw that out. We're going to imagine that we're taking the tables side by side. So here's the first table. The first table, as we can see, is 1, 2, 3, 4, 5. And here it is 1, 2, 3, 4. So my 5 times my 4, you can see the 20 right there. This side is 2. It's still 5 times 2. So the distributive property says, well, why don't I just add 4 plus 2 and get 6, multiply it times the 5 for an area of 30 feet squared. Let's try this. 6 times 5 plus 7. I'm thinking, I have 2 tables. One table is 6 feet by 5 feet. The other table is that same 6 feet by 7 feet. If I use the math, I can use the distributive property and say 6 times 5 is 30. And 6 times 7 is 42. I can take those 2 numbers and I can say 42 plus 30 is 72 units squared, if that were an area. This one doesn't necessarily have to be. If I look at the problem over here, you can see that here's the 6. The 6 is in both dimensions. That's the number that is on the outside. Here's my 5, here's my 7. I can add those together and make the problem be 6 times 12, which I know the answer of 6 times 12 is 72. Let's try one more. 9 times 8 plus 6. Try this one and then check back in. Did you get the correct answer? As we check over our work, we see that the 9 is used to multiply by both numbers. So it goes on the short side. Then I have 8 times 6, not drawn to scale. 8 plus 6 is 14. The answer is 126. Same answer. Just depends on which one is going to give us a clearer picture of what we're asked to do. So now follow up, ask questions of your teachers, and then check into the next video to see how else we can use the distributive property.